Hello everyone, welcome to 821 Day 1. We're going to be talking about complex numbers today. So this is a new type of number that you have probably never seen before. So we're going to talk about where those complex numbers come from, and we're going to talk about this number I and the powers of I. And then we're going to learn how to perform simple operations with these new numbers and simplify expressions containing these new numbers that we call I. All right, so let's kind of talk about where these numbers come from. All right, so a while ago there was a theorem called the fundamental theorem of algebra, and it essentially said if you have a second degree polynomial, then it must have two roots, or essentially it must have two solutions. So an equation like this is a second degree polynomial because we have an x being raised to the second power. So this theorem is telling us that there must be two solutions to this equation, x squared plus 1 equals 0. All right, so let's see what happens when we try and solve this equation. Let's see if we can find these two solutions. All right, so we would draw our line and we would practice what we do in algebra all the time, right? We would try and get x by itself, so we would subtract 1 from both sides of the equation. All right, so the 1's cancel, and we get x squared. And over here we do 0 minus 1, so we get negative 1. Okay, so, well, we don't want x squared, we just want regular old x, so we're going to undo a square by square rooting, right? So I'm going to take the square root of both sides of this equation, and we know that a square root and a square cancel each other out, right? So the square and the square root cancel, giving us just regular old x, which is what we wanted. And then we look at this side of the equation, we say, okay, well, the square root of negative 1. And so we have to think, if I want to find the square root of negative 1, we need a number such that when we multiply it by itself, we get negative 1. You're probably thinking, well, 1 times 1 might work, right? So if we do 1 times 1, we get a positive 1. Okay, so that's not negative 1. Well, okay, well then obviously it's got to be negative 1, right? So if I do negative 1 times negative 1, well, a negative times a negative is still a positive. And we run into an issue here because there is no number that we could square to get negative 1. There's no number that you can multiply by itself to get that negative 1. So the issue becomes, it looks like there's no solution since there's no way to evaluate the square root of negative 1. Since we have to have two solutions, it turns out that the square root of negative 1 is in fact a number. It's a brand new kind of number that we call a complex number. All right, and remember, when we take a square root, we get a positive and a negative version of it. So we're going to get a positive and a negative version of the square root of negative 1. And this is a brand new number. And we say that they represent this number with I. We say I is equal to the square root of negative 1. Okay, so this is a brand new number. We call it a complex number. All right. Other math textbooks might refer to this as an imaginary number, which is why they use the I to represent it, but it's not imaginary, it's a real number, which is why I don't like the naming imaginary, so we call it complex number. All right, so this is a complex number. So let's see how this number works, right? So how does this thing work when we encounter it? All right, so we're going to run with this definition. All right, a little bit of history here. Back in the 1500s, it was Raphael Bombelli who discovered this number, and he essentially dubbed it the imaginary number. But like I said, it's not imaginary. It is a number that exists. Okay, and he called it I. All right, and he defined it as I equals the square root of negative 1. So let's say we do something else, like the square root of negative 4. And according to this, it says the square root of negative 4 equals 2i. And here's why. Okay, so if I take the square root of negative 4, I can rewrite the negative 4 as negative 1 times 4. And when we simplify radicals like this, or when we simplify square roots, we can actually separate those products. Okay, so we can say the square root of negative 1 times the square root of 4 and evaluate those individually. So as Raphael said, the square root of negative 1 is simply I, and the square root of 4 is 2, and when I do I times 2, we just get 2i. keeping in mind that I is really the square root of negative 1. Okay, so we can say the square root of negative 4 is actually 2i. And we can do the same thing here. We have the square root of negative 9. Well, I can rewrite the square root of negative 9 as negative 1 times 9, and then separate them, right? So the square root of negative 1 times the square root of 9. We know the square root of negative 1 is I, and the square root of 9 is 3, and I times 3 is simply 3i. And that's why the square root of negative 9 is 3i. Okay? And we can do it for pretty much any number. So like this one here, we would do the same thing. We would take negative 1 times 2, right? Rewrite that negative number inside of the square root, separate them, and replace with an I, right? So the square root of negative 1 is I. And then the square root of 2 is not a very nice number. It's a big long decimal, so we just leave it as the square root of 2. So we just say I root 2. Okay, so that's the most basic operation right now, turning a radical with a negative inside of it into its complex form, 2i and 3i and I root 2. Okay, so let's explore some powers real quick, right? What happens if I start taking I and raising it to an exponent like 2 or 3 or 4 or 5? Let's see what happens. Okay. So remember, we're using this idea that the square root of negative 1 is I. We're running with this definition. Okay, so if I take I squared, right, what that means is I'm going to take the square root of negative 1 and I'm going to square it, right? Because we know I is the square root of negative 1, and I'm going to square I, so I have to square the square root of negative 1. And we know that the square root and the square cancel. So we get I squared equals negative 1. All right, so we can use that as a definition now. We now know that I squared is negative 1. Okay, so what happens if we raise I to the third power? Well, I to the third power simply means I times I times I. All right, it's a number multiplied by itself 3 times. That's what an exponent of 3 tells us to do. Well, let's say I take these two, right? If I do I times I, well, that's the same thing as I squared. And then we still have a times I here. Well, from our previous problem, we know that I squared is negative 1. So I'm going to replace the I squared with a negative 1. I'm going to say negative 1 times I, and negative 1 times I is simply negative I. So I to the third is simply negative I. And what we're starting to realize here is that when we raise I to certain powers, it simplifies, right? So in the future, if we see something like I squared and I to the third, we should simplify those to make our expressions easier, right? When I say easier, it means easier to work with. Okay, so let's try it again. We've got I to the fourth. Okay, so I to the fourth simply means I times I times I times I. Okay, so let's say I group those up just like this, right? So I times I is I squared, and I times I here is also I squared. And we remember from the first problem that we did that I squared is simply negative 1. So we do negative 1 times negative 1. And negative 1 times negative 1 is positive 1, right? Because the negative times the negative is a positive. So I to the fourth is simply 1, right? Which is pretty astounding. We're taking something that's a complex number, right? It seems really complicated, and it simplifies to something as simple as 1, right? So if we ever see an I to the fourth, we get to replace it with a 1, which is really nice. All right, so now we're going to do the same thing here. Okay, so we've got I to the fifth, right? Which, again, we're going to use this same idea here, just rewrite it in an expanded form. So we're going to say I times I times I times I times I, and let's group them up, right? So we've got an I squared, another I squared. So we've got I squared times I squared times I. And we know I squared is negative 1. So we've got negative 1 times negative 1 times I. And we know that negative 1 times negative 1 is a positive 1, so we have 1 times I, and 1 times I is just I. Okay. So I to the fifth is the same thing as just a plain old I. All right, it seems kind of weird. All right, let's do it one more time. We're going to do it for I to the sixth, right? So we would get 6 of these i's lined up being multiplied. There's 4, 5, 6, and then we'll group them up, right? So we got 1, 2, 3 I squareds. So I can do I squared times I squared times I squared. And we know these are all negative ones from our original definition back here, right? So we would say negative 1 times negative 1 times negative 1. So we know negative 1 times negative 1 is a positive 1, so we still have 1 times negative 1, and 1 times negative 1 is negative 1. And we find that I to the 6th is simply negative 1, which is what I squared is. All right, so as we run through these exponents, it starts to repeat. Right, so I to the 7th is going to be the same thing as I to the 3rd, and I to the 8th is going to be the same thing as I to the 4th, so forth and so on. Right, so that's the idea of powers behind I, and as we get into more complex expressions involving this I number, we're going to see some large exponents being applied to the i's, but we know that we can simplify them down to one of these 4 numbers, negative 1, negative I, 1, or I. Okay, so that is what we need for the powers of I. Let's take a look at some expressions that we might run into where we can simplify a little bit. Okay, so here we have the square root of negative 25. So we're going to take that first principle, right, where we are going to separate the negative 1 from the 25, right? So I'm going to rewrite this as negative 1 times 25. And then I can say the square root of negative 1 times the square root of 25. And we know the square root of negative 1 is I, and the square root of 25 is 5, and then I times 5 is 5i. So we can take this and simplify it to 5i. Okay, so let's try something like this, because we're gonna see some situations where we multiply two numbers with I, like this one, 2i times 3i. Well, we can multiply the numbers first, so we can do 2 times 3, which is 6, and then when we do I times I, we get I squared. And from our previous examples, we saw that I squared was simply negative 1, so I can say 6 times negative 1. And 6 times negative 1 is just negative 6, right? So we can say this expression, which has i's and other numbers and stuff, we can just simplify that to negative 6. Okay. All right, one last one here, just to continue seeing those operations. We have a complex number being squared. And be careful with these parentheses. When you have something inside of a parentheses and the entire parentheses is being squared, everything in the parentheses has to be squared. So we have to apply this 2 to the 2 and the I. Right? So 2 squared is 4, and then I squared. Right? I to the second is I squared. And then we still have, we're multiplying by negative 5i. Okay? So just like with this one, I can take the 4 and multiply by the negative 5, so that's a negative 20. And then if I do I squared times I, well, that's I to the 3rd. Okay, and I'm going to go back up here real quick because I remember I to the 3rd. There it is. So I to the 3rd is just negative I. So I'm going to come down here and I'm going to replace I to the 3rd. So I'm going to say negative 20 times negative I. And we know that a negative times a negative is a positive, so we can just say 20i. So this entire thing, as complicated as it looks, simplifies to something as simple as 20i. Okay, we're going to be exploring some polynomials, and we're going to start finding roots, and what we're going to realize is that some of those roots that we find are not going to be real numbers. Okay, they're going to be complex numbers like what we're seeing here in the video. All right, and when we get to finding those roots, we're going to have to be doing these operations like this, so we've got to learn how to deal with those. All right, so give the practice problems a try. Let me know if you have any questions, and I'd be happy to answer them. Have a great day.